Okay, we start with the analysis of a feedback amplifier, general amplifier. Uh, the basic amplifier is unilateral. Uh, what does that mean? That if you give an input, you get an output. Okay, it does not mean if you give an input at the output, you will receive anything at the input. So it is a unilateral device or circuit. However, please remember that when we evaluate for basic amplifier design, even with feedback, if I want to know what is the basic amplifier with feedback, so the first thing I want open loop amplifier. But in evaluation of gain for open loop amplifier, please do not neglect the loadings of components which you are going to create there by feedback. So what essentially we are saying that even if we are looking for open loop circuit, the effect of feedback network and source and load resistances be taken care in your analysis for open loop. So otherwise you will say you remove RF or whatever resistance or impedance you are putting and just do not solve for it. So use that impedance well in the circuit for open loops. Let us see how we will do it. We also assume in most cases that the feedback network is unilateral. Okay. Essentially we say there is no or very little feed forward in this case. So when as I again and again saying, I am actually first trying to find the open loop gain. Why? Because the closed loop gain with feedback is open loop gain divided by 1 plus A beta. Okay. So I want to know what is AOL, but in evaluation of AOL I do not want to neglect the circuit parts or components which would have come after the feedback. Okay. So that those I want to retain some way. So I have given, I am writing down here for you, or I have written down for you the steps which you can follow whenever such analysis has to be performed. So the first thing in any feedback amplifier is to identify the topology. What does that mean? Whether the what kind of feedback is it is, what is the sampling kind and how it mixes at the input, whether it is series sampled, shunt sampled, series mixed or shunt mixed. And if we know that, then our analysis will become relatively simple if we know which kind of amplifier we are considering. Okay. So first thing is, given a network or amplifier circuit, first find which kind of feedback topology this amplifier has. Then let us say for example if you have a series mixing, and if in the input circuit, if in the input circuit there is a circuit component say W which is in series with the signal source, then the feedback signal is XF equal to VF is a feedback signal. Okay. So we will see what does that mean. However, if you have a, that means please remember if it is a series connection it must be voltage in series to the source. Okay. Whenever it is series mixing, it has to be a voltage source in series to the signal source. That is what we described as series mixing. However, if you have a shunt mixing, the feedback must return the current, okay, because at that time the current will only allow you to shunt across the input terminals and the source will be current source. Okay. So depending on the kind of input you see, whether you have a feedback which leads to shunt mixing or series mixing, first you should find. If you know series, it is the voltage is in series in the feedback. If it is shunt, then it must be the current which is shunted across. Those topologies which I have given you 4 figures, please revisit them again and check what I am saying. Is that okay to you? Okay. This is just whatever we did in nutshell I am now saying, so that this is the method you should follow in any amplifier analysis and later on designs. Having seen whether it is which kind of mixing, we also will like to see which kind of sampling. Okay. I repeat, if the sampling is the mixing is series, the feedback must be voltage. If the mixing is in shunt, it must be a current which is in shunt to the input circuit. Is that okay? Typically shunt circuit will occur when the current has to be brought there, where it will current can be mixed with some other current at a node, is that correct? At a node. Voltage can be in series when it is in the mesh, is that correct? Only then it can go into the series of the source, okay. So think of it, whenever there is a node connection feedback, it must be shunt kind. Whenever it is in loop kind of input inside that loop, it must be a series feedback which must be voltage, is that okay? Okay. So obviously in a mesh you cannot have current additions there, okay. So this is trivial but must be understood and must be solved correctly, because otherwise there will be a mischief in actual solvings, okay. So having said that this is how it will mix, to get the sampling set the output 0 which is your output, okay. Essentially you say short the load, okay. If now Xf becomes 0, that is if output is V0 and you are shorting, and no feedback will go because part of V0 was to be fed and you have shorted it actually. So if feedback goes to 0, then you must be obviously voltage kind of sampling, which is essentially shunt sampling across the output, is that correct? Across the output means shunt. Figure is shown here, this is I have shorted the output, and as soon as I short the output the feedback goes, okay. Because I say something by V0 and if V0 is not there, there is no feedback there, okay. So once I know it is this kind of circuit I short and I say I do not see any feedback, then I say I must be having a voltage sampling which we defined as shunt, because it is shunt to the output, therefore it is a shunt sampled. On the contrary, if I make I0 0, which is I open circuit the resistor output load, okay, then if Xf becomes 0, then it must be in series to this, because then you are open circuit in the loop and therefore no current can go, and therefore we say you are series sampling, and that is what the current sampling will be, is that correct? So the conditions you should do, first see at the input side whether your source is getting in the loop of this, then it is a series, if not it's shunting, then it is a current. So series shunt mixing we know, by making V0 or I0 0, if your feedback goes to 0 we know which kind of sampling we have done, okay. So having now known whether it is series amplifier, series shunt amplifier, shunt series amplifier or a shunt amplifier, I know which topology now I am at, okay. So given a circuit, first thing you have to find by doing this simple which topology we are, because you know in the circuit this kind of network will not be shown, it will be a formal circuit with some components connected left and right, okay. So from there you must be able to figure out which topology we are working at, okay. Also we have seen, depending on the topology, input resistance and output resistance change, in some cases it increases, in some cases it decreases. So the topology will also tell you how the input output will respond to the input side addition, anything coming, or output side when it is driving. So some idea of Ri, Ro also should be immediately known, because you know now that what kind of amplifier I am working at, is that okay? Now these issues a priori you do it, because as soon as I put a network or circuit you should be able to find what I am doing, okay. I will give you an example, do not worry that this is the end of it. Now the next step, having found the topology, I want to find amplifier without feedback, and I just said to start with what I am saying, even if I want an open loop circuit, I do not say feedback network has been removed, is that point clear? Feedback network has been, I am not saying it, I say I want feedback be broken but the effect of those components still be taken care of, okay. So let us see what I am saying little later. Step A, in the input circuit, if I am looking for what is happening because of the feedback in the input circuit, if you have a shunt sample make V0 0, and if it is series sample make I0 0, okay. Essentially the feedback you want to remove, okay. Then the step B is, first I figure out something, I will give you examples. To find an input circuit make V0 0 if it is shunt sampled, make I0 0 if it is series sampled. Now to get an output circuit, what do? Make V input 0, okay, if it is current mixed, and if it is voltage mix, remove the input current. So either of the case you already find the topology, so which know which ones have to be shorted or opened as per the conditions we have done, okay. Now these two conditions once we do, इसमें कोई ओरिजिनलिटी नहीं, इसमें आपको एक मैं मेथड इसलिए बता रहा हूँ कि people normally do analysis without knowing also its answers come correct, nothing big about it. But methods, why they are shown these methods? Because they are short, they will simplify your job, that is the only reason we show all the methods. Otherwise what is the big method is, put whole equivalent circuit and solve, it will always come at the end of the day, okay. So to even do this, can I simplify few things beforehand, I do that, okay, that is the trick we want to use. So what is that I am trying to say? I want to find the closed loop gain with feedback by not directly calculating with all components present as normally should have been by Kirchhoff law. What I am going to use the expression for closed loop gain? Open loop gain divided by 1 plus AOL beta. That is the expression I had derived for feedback. So I will say, okay, I will calculate AOL, I just calculated beta, I substitute, okay. And I am sure that calculation of AOL will be much simpler than calculate of total ACL, this is my belief. If it is not your belief, solve all of it. No one is saying you have to solve ACL by first getting AOL, you actually can solve full network, and once you write an equivalent circuit you can always find V0 by Vs, is that clear? So there is that method stands anyway, okay. These techniques are only trying to minimize the effort. So if I get my AOL, fair enough, I know my beta, then AOL upon 1 plus A beta is my closed loop gain, feedback gain. So I just want to do the two steps now. So one of the step I should say, once I know what is XF, because I just know sampling as well as mixing, so I know what XF I am talking, then what X0 I am talking, is that correct? So the ratio of XF by X0 is your beta. Please remember XF, XS is the return path coming from V0 side or I0 side. It can be resistor, it can be conductance, or it can be voltage ratio or current ratio, is that clear? 4 possibility can exist. I may return as a I, V may return as a V, V may return as I may return as V. So in any case there are 4 possibilities of the beta's value, is that clear? Because A beta should have what units? Irrespective what is A, whether it is current gain, voltage gain, transconductance, what should be the A beta? Non-dimensional, or it should not have unity. That means A beta must be opposite that of A in the units, is that correct? Therefore then only it becomes dimensionless. This is essentially what we are saying, okay. So first find beta, then get AOL beta. If you already calculate AOL, then you get AOL beta, that is T function. Evaluate closed loop, which is also in some books called AF for the amplifier, by what function? AOL upon 1 plus AOL beta is the closed loop gain. So evaluate that, and then also evaluate, as we did already earlier, what is its RIF and what is its ROF. These are the 3 parameters of interest to us other than frequency response, which we will see later. Okay. For normal amplifier, first thing I want to know gain, how much gain I got, and what are the input output impedances I am going to get. Okay. So is this method clear to you? So what is first thing we will do? First thing we must find the topology. To get the topology we must find what is the kind of mixing and what is the kind of sampling. From there we know what is the feedback going on, okay. Correspondingly you actually find your beta. Using the network available of feedback, and that is what to get an AOL, we will see with example that will prove my point. Find AOL, you know the beta, and therefore you know the closed loop gain. But by the same circuit you can always get your RIF as well as ROF. Let us do one example which will clarify what I am saying. Okay. In normal cases, unless said otherwise, assume feed forward is negligible, okay, unless said otherwise. Okay. You can see it is like superposition. We always solve for feedback, okay, and if there is a feed forward, which term will appear in gain function? A 0 will appear. So that means there is a partial feed forward path is going on. Is that clear to you? So if there are zeros, this means there is some feed forward is going on anyway. Is that clear? Otherwise poles will always give you feedback. Is that correct? This is what the technique is to know whether we are doing correctly or not. Okay, here is an example which is very simple and very easy to understand. Let us say I have a source follower, emitter follower, which is essentially called common collector circuit. Please remember the other name of emitter follower is common collector circuit. Okay, collector is grounded at the VCC. Grounded means to go to VCC. There is a source Vs, there is a source resistance Rs, there is a load which is Re. Please remember this Re itself is the load for source amplifier. There is no additional load, it may have also, but right now for this we will just take Re, and output is taken across this. Equivalently saying, this is a VBE for the transistor. Please remember Re is common to the mesh of the voltage drop across Re is common in this mesh. Do you see this mesh? In this mesh the drop across Re is in series with Vs, So what mixing I am doing? Series mixing, okay. However, if I short V0, nothing goes inside the feedback. So what sampling I am doing? Across I am sampling. So what is this? Shunt sampling and series mixing. So what amplifier I have? Series shunt amplifier. Is that clear? If I short V0, no feedback, drop across Re becomes 0. So nothing changes in the input, no feedback in the input. So it is essentially voltage feedback which is shunt across the output. Okay, so it is a shunt sampled. At the input side, if you see this mesh, this drop across Re is in series with the source. So you have a series mixing and shunt sampled. So it is series shunt sample, or it is essentially called voltage amplifier. It is called voltage amplifier. Okay. What is series? We said then the feedback signal is in series with the source, and that can only be voltages. Current cannot be in series with something, isn't it? So only voltage can be in series. So if you look at this input loop, input circuit, the drop across Re which is common, which is the feedback, see V0 by this much is the current, drop across this Vf, that is in series with the signal. You can see this series. In this is actually twice, one because of Ia and one because of this, but for the input side this current takes care of the drop across this. So whatever voltage Vf here is in series with the signal. Whenever there is a mesh, the two voltage sources can be in series. They may be plus or minus, depends on the signs, but they will be in series. If you have a node like this, there is a current here, there is a current here, and something like this. What is the mixing done here? I can add a node I brought, let us say this is one I1, this is I2 and this is I3. So I3 is I1 plus I2. So it is node mixed, that means current is getting mixed. Is that correct? Which is essentially shunt to the input circuit. Current is always shunt, source, is that correct? So we say whenever there is a current feedback going on at the series at this, it is a shunt feedback going on, shunt mixing is going on. If the voltage across the feedback network is in series with the source, then we say it is a series mixing. Is that correct? That is a voltage mixing. Please remember, series cannot be currents, it always will be voltages. So it is therefore voltage input, voltage output. So what amplifier I am looking for? A voltage amplifier. V0 by Vs is my A. Is that correct? That is the way I have figured it out. So it is a series shunt amplifier, which we have already done earlier, but let us do it again. Okay. just to say again, since RE is common between input and output, this amplifier is a voltage amplifier circuit. Now we want to find circuit without feedback, okay. I repeat, I want to find AOL, which is I say circuit without feedback, but what is the condition I am still forcing you? Do not neglect the feedback components, because if you neglect them, then the feedback part will this will become normal amplifier, there is no question of feedback there. So if we say at the input, what is the condition I said to get an input circuit? Short the output, is that correct? Short the output. So I said V0 is 0. So what things get shorted in the input side? The Vf, because if V0 is 0, Re does not exist, it is a short circuit. Please look at the circuit again. If V0 is shorted here, this is grounded. If V0 is grounded, this is grounded, okay. So in the input side, I have Re bypassed now by short, okay. This is my input circuit now. This is my input circuit. Now to get an output circuit, what is the condition I told you? Short input. So okay, if I short input, II is 0, if we make II 0, there is dependent source on the output, we have circuit only in the, what happens here, if I say this is going down, the GM times that will also go away, okay. So what will remain at the output therefore? Only the Re factor, GM times parallel Re, but GM itself will be open circuited, GM Vi, current source is open circuited. So what is the resistance seen there at the output? Re. So that is the circuit I put. This is my input circuit, this is my output circuit, is that correct? So this is which amplifier now I am calling this amplifier? It is a open loop amplifier for the feedback circuit amplifier given to me. Take to get an input circuit, short V0, and then whatever you see in the inputs, that is your input circuit. To get an output circuit, short inputs, but as soon as you short input, GM Vi will open up, because there is no current source then the only resistance, of course there is a RO, but right now I say RO is infinite. So the only resistance left is Re at the, please remember you see circuit again and again. So if I see from here and this is this, the only resistance I see is Re, nothing else at the output, is that correct? So if that happens, then the equivalent circuit of a transistor now is a common emitter amplifier with Re as a load, drop across Re is the feedback voltage, and then I write equivalent circuit of this is Vs R pi, okay, bipolar hai, Vs R pi, Gm V pi, this is my emitter, this is my base, this is my collector, Gm V pi parallel R0, if you want to make R0 infinite you can make that, parallel Re, and then I can get the gain of this amplifier. क्या होगा gain बिना मैंने कुछ लिखे, कितना gain होगा? ये V pi है ना, कितना होगा? Gm V pi times RO parallel Re is the output voltage, but V pi is how much? R pi upon R pi plus S times signal, is that okay? Potential divider, ये voltage कितना है? This voltage का divider है, this upon this plus this into Vs is V pi. So substitute V pi in the output, so V0 by which is Gm R pi ROE up, ROE is the parallel combination, I make R pi plus Rs. So this is my open loop gain. Is that clear to you? How did I get my open loop gain? I got my input circuit, I got my output circuit, then I made a new amplifier now for me, and I got the gain for this amplifier, which I say it is open loop amplifier gain. See, normally it is a common emitter amplifier. We have seen what is for a common emitter amplifier, what is the load resistance we are seeing, output resistance, which is Re. So it is a cross collector to emitter. That is the equivalence, that is what I keep saying. It is not symmetric, same as what we have, it is source amplifier, common emitter amplifier, common collector amplifier, that is emitter followers, have an equivalence with a feedback of that Re is of this kind in open loop. This is something you have to appreciate. This is the output resistance Re I got. What is output resistance will be across what? It will be always across collector to emitter. Okay, that is the output resistance of an amplifier. Substitute there. Okay, then solve this. Once I get this, then how do I get the gain? Okay, before the, what is beta? Unity. It's same voltage ना, वही feedback पे गया है. So beta is 1. So the return loop gain T is AOL beta, which is this function. And then the feedback gain or a closed loop gain is AOL upon 1 plus T. Substitute these values here and you get beta ROE upon R pi plus RS. Now I am now giving you a case. This already we have solved source amplifier, is that clear? We already solved normal common source, source follower and emitter followers. Don't use feedback theory. What do? Don't use any feedback theory. I actually solve equivalent circuit for this, is that as it is. Then evaluate this gain for that V0 by Vs and verify whether using this AOL upon 1 plus T kind of function, is this expression is same as what I would have got if I would not have assumed any fee, I just solve the network. Okay, verify yourself and you will be surprised, it is exactly what we got otherwise. Okay, and why positive sign is coming everywhere? Because source followers or emitter followers has a same phase outputs as inputs. Okay, by same logic we have earlier said, what is RIF for such series shunt amplifier? RIF is 1 plus T times Ri. What is Ri? This is 1 plus T. What is Ri? Please look at our circuit, equivalent circuit. What is Ri? Is only R pi. Please look at the circuit. What is Ri here? R pi. R pi times 1 plus T is the RIF. That is what we have already said, series shunt amplifier. We have evaluated RIF, ROF already for in terms of Ri and RO. So I substitute here and I get roughly, if I solve it, R pi plus beta ROE. Do you recollect this very well, that we said if there is a source follower or emitter follower, its input impedance actually increases by beta times the feedback whatever Re there plus R pi. This may be very small, actually this may be much larger value. So the input resistance of a series shunt amplifier is very high, okay. That is what essentially we want, that is why it is called what? What is the other name for common name, this source followers or emitter followers? Buffers. The buffers have larger input resistance and smaller output resistance. So let us calculate output resistance, you can do yourself, that is not a big issue. What did we calculate for this shunt sample RO? RO by 1 by T, we have done all that. What is essentially RO for this? Small RO. Please remember Re is outside, it is a load, so the only resistance is RO. For this RO upon 1 plus T, if I substitute it Rs plus R pi by beta, beta being very high, Rs is typically few hundred ohms, R pi is typically 1 or 2 kilo ohms. So it is say at best 2 kilo ohms by 100. So how much it will be? 2 kilo ohms by 100, 20 ohms, is that correct? Let us say it is, this whole becomes 2k divided by 100, how much it is? So the output resistance of a emitter follower is very low, typically of the order of, for example I gave you say 20 ohm, 50 ohm kinds. And how much is the input resistance will be? Let us say Re is 1 kilo ohm, so how much is Ri will be? RIF? Beta times Re, it is hundreds of k, is that correct? Hundreds of k. Is that what we did in normal source or emitter follower? You can verify once again, I repeat, yes, Re is what? Re is shunting load is let us say 1k. So in feedback it is 100k at the input side, beta times Re it will be reflected. So input resistance will rise to hundreds of K, okay, whereas output resistance will be how much, 10 to 20 or 50 ohms. So buffer requirement, that the unity gain with high input impedance and low output impedance is achievable by source follower or emitter followers, and this problem can be solved using feedback. Is that correct? Whatever analysis we did without feedback knowing also, we solved the network, equivalent circuit रखा, network solve किया, okay, वो सब भी जो करेंगे उससे result यही आया, that means our feedback, you are asking the verify, here is a verification, okay, you verify both value, there will be some small change may occur because of some approximation we are making here there, but if you do not make any approximation they will be identical in both cases, okay, is that okay? This is a technique which essentially we use in feedbacks, okay. So what is the method, I repeat, what is the method I suggested? First find topology, then find what is the mixing going on, sampling going on. Once we know what is their Ri and Rof can be, because either by 1 plus T or multiplied by or divided by whatever the topology I get. I also know to get an open loop circuit, first I say short input find the output, short output find the input, make a new amplifier using this input output circuit with a transistor as usual, solve the gain for that, that is your AOL. If you know the topology, you know the beta, whether current by voltage, current by current, voltage by whatever you are getting, so you know the beta, you know AOL, so you know AOL upon 1 plus AOL beta is your common closed loop gain. Is that clear? With feedback. I told you that output resistance is defined for the transistors and not for the loads, Re is the load. Yeah, but that is, we will take always as seen by the transistor. Ro is the resistance as seen by the transistor. Any external component you do not add to it. Is that correct? That is the definition we say. The final RIF or ROF will be shunted or by this and whatever the other side. Is that point clear? The actual someone asks you RIF, so you calculate that, okay. Then you say the net RIF dash whatever you call, then you are looking from the source side and you are looking from the actual output side. Then whatever parallel or series combinations they get, you write for them. So in this case, whatever ROF I got shunted by Re, whatever I got here RIF in series to this. Is that clear? So that method remains, where to calculate, यहाँ करना है या यहाँ करना है. First we always calculate at the input of the amplifier, at the output amplifier, and then actual outputs with loads and actual current, voltage or current sources वहाँ भी निकाल सकते हैं. But that is, once you know this is only additional. Is that clear? But the definition wise we always do this. Is that clear? This is nothing to say that why we do not want to use the other values, because the source things I do not know what is RS value, what is RE value. So I say intrinsically इतना है, अब जो भी component लगाएंगे वो उसको modify कर देंगे. Is that correct? That is why we do not want to use those values in our actual definitions. Is that clear? But you are right, the actual impedance phase will be somewhere at the output side. So वो उसको देखो किसके पास पैरेलल होके किसके या सीरीज में आ रहा है, वैसा जोड़ो, बाकी सबस्ट्रैक्ट जो भी करना है जैसे भी वो करो फिर. हाँ, okay. If I have an equivalent circuit of that GM V whatever V pi we are doing, if the source is 0, then the GM V pi is 0, which means current source is in open circuit. So the only impedance seen by me was Re there. Okay. If that be VB and GM VB आता तो वो 1/GM वहाँ आता, ऐसा नहीं हुआ तो उसको हटा दिया हमने. Is that okay? Okay, so these techniques which I suggested, maybe one more example on the MOS will clarify some more doubts. Okay. शंट एम्पलीफायर है, अभी मैं पहले बोल दिया शंट, अभी आप कहो तो आप वेरीफाई कर लो. Here is a current node, as soon as I say current feedback इधर से आ रहा है RF के साथ में ऐसा, of course your plus minus sign you correctly decide, feed forward मत लेना. So what we say, as soon as I make V0, there is no current at the input, is that correct? As soon, that means its feedback is removed by me, which essentially means this is a what sampling I am done, a shunt sampling I did, and when I say at this site, at this node all three currents can meet, so it can change at the node any current, and therefore it is shunt mixing. So I have a shunt mixing and shunt sampling, so this is shunt एम्पलीफायर. फिर से एक बार खुद देखो, वेरीफाई कर लो. जो मेथड अभी तक बताई हैं वैसा का वैसा इसमें अप्लाई करो और वेरीफाई कर लो जो मैंने किया है कि दिस शंट एम्पलीफायर. So we first figure out what is the topology. So I said it is shunt by, actually I knew it because I am actually seeing it. यहाँ नोड है और यहाँ इसका जीरो करने से जा रहा है, तो ये शंट है. Is that okay? V0 जीरो करो, नो फीडबैक, करंट जीरो कर दिया वहाँ से. ओके, सो वोल्टेज सैंपल हो गया है, दैट मीन शंट सैंपल हुआ. इस yes, if V0 is zero, no current from the output is going to the input side. This is a zero potential. Is that clear? So we said as soon as I get output 0, no feedback. V0 0 kiya, that means I am sampling voltage. No, this sign I have just made for the, don't see, IF will be in below down actually. If you wish you can always use plus or minus sign. That's what I say, we always write signs as they actually appear, okay, as they actually appear. At a node this will only plus or minus it will do. So signs will be correctly done whenever, I just want to show you at a node, if the three currents meet, the sampling must be, mixing must be how much? Should be shunt mixing, because currents are getting actually shunted to each other. Okay, so this shunt amplifier of a MOS, I can now show you how do I do it. Here is the circuit equivalent. Here GM VGS is your source, this is gate to source. Right now I assume source voltage is 0 and this is my RF, is that correct? From drain to gate is my feedback resistor RF, is that circuit clear? Drain to gate is the feedback resistor RF. This is GM VGS R0, this is my RD and this is my source. Now to get an open loop, okay, I said V0 0, input circuit ढूंढना है ना, so what should I do? Short V0, as soon as I short V0, this terminal goes to 0, whole of this terminal is going to 0, that means RF का दूसरा terminal कहाँ जा रहा है, कहाँ जा रहा है, ground पे, ये ground पे आ गया. Is that okay? As soon as I make V0 0, this terminal is ground, so its source was ground. So that means the RF is between gate and source, RF resistance appears when the V0 goes to 0. So the input circuit has a resistance shunting there as RF, is that clear? Okay. To get in output circuit, what should I do? I said short the input, okay. If set Vin equal to 0, even this goes to 0, so opens it. So what is the output resistance? See, output things I see, RO, RD. Now this is shorted. Please remember, this other terminal is shorted now. So where it will now come? From this to the ground. So now I see RO, RD, RF in parallel at the output node. Is that correct? At the input what is there? RF shunting gate and source. At the output I have three resistances in parallel shunting the output, RO, RD and RF. ये कौन सा एम्पलीफायर के लिए बनाया जा रहा है? Open loop. Is that correct? This is for getting the AOL. But remember I have not removed, what does that mean? Without feedback. So what would I have done otherwise? Without feedback में क्या करते आप? RF को हटा लेते और जैसे RF को हटा लिया उसका open loop हो गया वो, that is true, but then these values would never have been seen by open loop case. So the loading effect of the values cannot be neglected in evaluation of open loop gains, though feedback is still broken by us. You can see now if I say equivalent circuit of this, this is the input side RF, this is the output side. Now there is no connection between input and output, so this is open loop. This is input, this is output, no connection from drain to gate. So I have broken that, so I have made it open loop. But what is the criteria I have chosen? That the loading of RF I have not neglected, loading of RF I have not neglected, though broken I have certainly broken the feedback, okay. This is called open. So this, is it point clear? It is different from what we call without feedback word, because without feedback means you would have just taken RF out, is that correct? So we are not taking RF out, we are saying for feedback break it into, so that as if there is no output input connections, equivalently saying this is the circuit. Okay, since it is the shunt mixing means it should have a current source, so voltage by current is the amplifier. So AOL is V0 by IS star, star I am making for open loop, okay, star I am only trying to make it open loop. So AOL is VO star upon IS star, which is VO star by Vin into Vin by IS star. This method, do you know how? Don't write directly V0 by IS, essentially what do you do? V0 by Vin into Vin by IS star, ये cancel ही हो रहा है. But this value I know by a normal amplifier, how much is this? V0 by Vin minus GM times the load. कितना होगा आउटपुट यहाँ VO स्टार? GM Vin times RODF. So VO star by Vin is GM RODF, minus में है, minus sign है. How much is Vin by IS star? RF, there is nothing else, so into RF, okay. So I got, now correspondingly Ri if you see is only RF, correspondingly Ro if you see it is only RODF. ये कितना रेजिस्टेंस है RODF, ये कितना है Ri, इतना ही है रेजिस्टेंस हमारे पास. What is the feedback factor here I should use? Which kind of amplifier I said it is? Shunt. इनपुट पे करंट जा रहा है और आउटपुट से वोल्टेज सैंपल होके आया है. So IF star by V0 is 1 upon RF. कितना करंट फीडबैक से आया IF, वो कितना होना चाहिए? वो जो रेजिस्टेंस में जितना था उतना ही. बीटा, please take it verify, IF times RF is V0, okay. So उसका रेशो ही किया मैंने. So feedback factor is 1 upon RF. So अभी क्या चीजें पता लग गई? We know our AOL, we know our beta, so what we can calculate? Closed loop or feedback gain, okay, that I did. आप खुद करके देखो तो आपको ज़्यादा समझेगा, पर मैंने आपको दिखाया methods. Closed loop gain is VO. Please remember it is still voltage by current. So which amplifier I am talking in the real sense, not voltage. Which is this amplifier? Trans resistance amplifier. This is trans resistance amplifier, okay. So if I substitute all this, ऐसा गेम खेला, so बोल, पर हमको क्या चाहिए रहता है एम्पलीफायर में? What do you really need in normal amplifier? It may be trans resistance, it may be trans conductance, it may be current. At the end क्या देखना चाहते हैं हम? वोल्टेज गेन. At the end हम क्या देखना चाहते हैं? वोल्टेज गेन. So हमको एक्चुअल निकालने को कहा था V0 by Vin, पर हमने तो निकाला अभी V0 by IS, okay. So V0 by Vin can be written as V0 by IS into IS by Vin, दो पार्ट में कर दिया. V0 by IS तो अभी मैंने निकाल ही लिया यहाँ से. अभी मुझे क्या निकालना है? IS by Vin, okay. So if, no, don't write this you write now, don't do anything. Now this V0 by IS is GM RODF RF, ये जो ये है upon 1 G this, ये तो RF cancel हो गए. Now how much is IS by Vin? आपके सर्किट में देखो ना IS by Vin कितना है? 1 upon RF. आपके इनपुट सर्किट में देखो ना कितना है IS by Vin? 1 upon RF. मल्टीप्लाई किया तो ये फंक्शन आया. दिस इज योर एसेंशियली द वोल्टेज गेन, क्लोज लूप voltage gain of feedback amplifier. What kind of feedback amplifier we started with? Shunt. Okay, this is a shunt amplifier. इसका क्या फायदा हो सकता है, घाटा हो सकता है? इसका आ रहा है ज़्यादा होगा कि कम होगा? RF जो है feedback क्या, please look at your circuit and tell me your tables. In case of shunt amplifier, does Ri increases or Ro increases? Ri should decrease, current is subtracting out of it, so it is a negative feedback. So Ri तो decrease हो गया, पर Ro जो है 1 plus T times बढ़ गया. So it is opposite of what we did in the case of source follower or emitter follower. There input impedance rose, output impedance went down. By making a trans resistance amplifier, I can now make opposite of that, decrease the Ri and increase Ro. So this, is that clear to you? What is the feedback is trying to do? Feedback is trying to play whatever specs you are looking for. By choice of proper feedback topology, I can achieve Ri, Ro and gains of my choice. Is that clear? Is that point clear? Why feedback? Because feedback allows me to tailor my input resistance, output resistance and the gain, and that is something which normal amplifier does not allow me. Is that if I take a source amplifier, I can't do much of that, it will always be one kind. Okay. Feedback allows me to play. Okay. That is why feedback amplifiers, and what is the most important thing in feedback we are getting? It gain becomes constant, very close to a, why it becomes constant in negative feedback? If there is a change of signal due to noise at the input, and let us say it is plus, then what will become to the output? Additional voltage will appear at the output. So during feedback what it will do? It will start, that also will be higher now, correspondingly beta times V0. So the input will further rise now, sorry, it will opposite, it will rise but it will subtract. So in net input will go down, so the output will go down. Since output went down, feedback reduces. So it will start again till it balances to the normal value. So feedback stabilizes the gain and it also allows me to make different Ri, different Ro and different ACLs. Is that correct? That is why feedback amplifiers are always utilized. Please remember, instead of RF, what is normally will be present in the case of all amplifiers? This, I did not put RF there, but what component will be always there in a MOS transistor? Which capacitor? CGD. So please remember, CGD is a shunting actually between output to the input and it will give you a shunt mix. Is that correct? So it will also try to stabilize you, okay, with that impedance of that frequency. The only problem why it is so different from this, because it is a frequency dependent impedance. R is constant, but omega C, different omega will have different this. So at certain frequency it may have certain different phenomena, at other frequency it may have other phenomena, but that is what we want frequency response to be modified, okay. That is what CGD, CGS and others will actually help us to achieve that. Is that point clear? This is an issue which you should always understand, that feedback is a generalized network and sometimes inbuiltly present, sometimes you may actually put it, okay. When I say I put RF, in reality what do I put in such circuit? RF parallel CGD. So it is an impedance which I am putting there. Is that clear? So there is a some kind of a pole function starts appearing because of this RC network which I am going to put there. Is that clear? So if the pole changes, then what changes? Bandwidth. So you have to see that what kind of amplifiers will improve the bandwidth or decrease the bandwidth. Is that correct? These are the techniques of controlling the bandwidth, the gain and the Ri, Ro. Okay. That is why I say feedback is very important phenomena. I am not going to do a great part of stability, because why I was thinking to teach you a lot of things on that, Nyquist criteria, root locus method, but then I will go to the control side bit too much. Let us take that expression in closed loop, AOL upon 1 plus T I am looking for stability with feedback. If T is positive, what does that mean? If T is positive means 1 plus T is higher, means closed loop gain will be smaller than open loop gain. is that correct? Denominator will be larger, so obviously you will get smaller gains. Okay. What is the feedback? Essentially we say when this can occur, only when negative feedback is present. Okay. However, if t is less than 0, then the denominator will actually enhance, divide by smaller value, it will actually enhance the ACL, and if it enhances the ACL, if it is negative, then it will enhance, and if that enhances, what is the kind of thing will happen? If the feedback signal is always in same sense as the input, what will increase? The net input. If the net input increases, what will increase? The net output. The feedback will bring back additional input now, which is in series, which is in plus to the input itself. So further increase of input, further increase of output, what is it going to do? So at any given instant of time, I do not know what is V0, because V0 is constantly increasing, increasing. Is that correct? V0 return to the series of that increases V0, further loop में V0 बढ़ता जाए, उसको क्या बोलेंगे फिर? Amplifier does not have any known gain. Is that correct? Because every instant of time V0 is not known to me. Okay. So we say such amplifiers are unstable or they show instability. Would you like such things to happen for your amplifier? Why did we do feedback all this for this purpose? कि नहीं gain constant हो जाए भाई, जो हमको 10 चाहिए, 50 चाहिए, 100 चाहिए, we want that fixed. Is that correct? With nothing changing, this gain should not change. Everything changing, but this gain should not. अभी तो आपने पॉजिटिव फीडबैक किया तो वैसे ही सब बढ़ रहा है, ग्रोथ पैटर्न शुरू हो गया. So such will not be an amplifier. Is that correct? It will not be a amplifier for known gains. So any time positive feedback appears, we say we have instability. Is that correct? So guarantee क्या करना है आपको amplifier design में? What should you ever guarantee? That it should always be negative feedback. अब आप एक सोचो, आउटपुट जो है V0 is a function of frequency. If the input is a function of frequency, so the output will be a function of frequency. So there are two factors of any this return factor, this T factor, which is loop gain. If you see a loop gain, will it be a real quantity or an imaginary quantity or a complex quantity? A is a complex, so is A beta will be a complex quantity, T will be a complex quantity. Is that correct? So if it is a complex quantity, how do we represent any complex number? A plus JB is equal to magnitude of this value into e to the power j omega or j phi, which is the phase part for that. Is that correct? Any complex function can be represented like this. Is that correct? Tan inverse imaginary by real is the phase for that. So you have not only amplitude but also you have a phase. So now look at a situation which is very interesting. This इतना simple समझ में आ गया तो आपको easily सब feedback समझ में आ जाएगा. ये input है, ये एक network के through आपको यहाँ आ रहा है. This is much easier to explain. The closed loop gain is AS upon AS is, instead of AOL I am just removing OL. AS upon 1 plus AS beta S. Now my I am using little generalized. What is generalization I did from the earlier one? What is beta I am showing you? That may be also a function of frequency. Right now normally what is the kind of betas we have used so far? They are real values and there is no complex term with them. Okay. But let us say it is also function of, ठीक है उसको भी general कर देते. So we write at for a frequency ACL at j omega is A j omega 1 plus A j omega B j omega. The loop gain T is A j omega into B j omega is certainly a complex function. Okay. How do I write complex function? The magnitude of A j omega this e to the power j phi, which is a function of omega. Phi is the phase. What is phase? By definition of complex number, tan inverse imaginary by real value. So that's how we represent any complex value. Now look at the situation little carefully in that figure. let us say feedback is coming, okay. So it has some magnitude. What is being returned? Return has some value which has magnitude and also has a phase. If even if let us say the gain magnitude is higher than 5, 10, 20, okay, but the phase is such that the return signal opposes the input signal. So which kind of feedback it will give me? Negative feedback, is that correct? There is on the AOL itself, AS itself there is a phase shift. What is the phase shift between input and output for the AS? How much degrees? 180 degree. Amplifier shows phase out. So there is a 180 degree is a normal input to output. On the return part, because the complex function there is a phase going on. If this phase is also 180 degree, how much is the net phase it will give you? 180 there and 180 here. So how much is the phase now? 360 degree or 0, you are right. So what now let us say the amplitude is positive, then what will it will do? If the phase becomes 0 means in phase to the input, which kind of feedback? Essentially I have gone into positive feedback. The gain is not less than 1, gain is higher than 1, okay, but the phase was such that it is 180 degree from the feedback and 180 degree from the amplifier. So the return signal to the input is in phase with input, which is higher now because your A beta is higher, you have chosen 10 let us say, okay. So now what is happening, that your input has increased, output will increase and input will, so which system has become stable or unstable? Unstable. So it is not just the magnitude but also the phase, is that correct? So can you think from this a very simple calculations which we do, if we say at the frequencies of operations which we are looking, if the gain become, where is the gain will become 0 dB? At the omega t term, that is the unity gain point. So if we see for the loop gain itself alone, when it will become, when it becomes 1 t j omega is 1 magnitude wise, we said at that frequency, if the phase of this function is how much? Less than 180 degree, I repeat less than 180 degrees, which feedback I am still talking? Negative feedback. But if the gain is positive and feedback this has already crossed 180 degree phase, then what will happen? The feedback will become positive. I repeat, the gain is positive, it has not crossed 0 dB, loop gain for example, and its phase has crossed 180 degree, okay, or reached at 180. So now what will happen? There is a positive return, positive value which is in phase return to the input, is that clear? So which feedback I am now getting into? Positive feedback, system will become unstable. So the two terms we define, one we call phase margin and the other we will call gain margin. If the phase margin is positive, we will see that, then we say system will remain stable. If the phase margin becomes negative, then we say system will become unstable. So all feedback amplifier people try to see what is the phase margin they are getting, is that correct? If the phase margin is positive, be assured that, what does that essentially mean? Phase margin is negative means when the gain becomes less than 0 dB or less than 1, your phase is still negative, is that correct? So it has not returning signal and the gain has already crossed 1, so it is partially is only returning now, much lower is returning, and you are always opposing that value, is that correct? So what does that mean? That if the Bode's plot, think of it, something on the Bode's plot, if your 0 dB point crossed by the magnitude, at which point the phase is still not 180 degree or 0, essentially 180 plus 180, then what do we say? The negative feedback exists. If that crossed before, after this, then we say it is a positive feedback and we have a instability. So is that point clear? So in amplifiers it is not only the amplitude which is also, there is a problem of phase, and that is what essentially the stability is all about. Okay, just even to give you a basic idea, any generalized transfer function in a feedback can be written as, इसको ही expand किया तो AF0 1 upon, there may be large number of poles A1S by 1 plus with feed, this is all with feedback. इस ट्रांसफर फंक्शन को इस तरह से लिखा जा सकता है जनरलाइज फॉर्म में, A1 प्लस A2 प्लस A3 S स्क्वायर S क्यूब S4 Sn, कितने भी पोल हो सकते हैं. What does this essentially means? If there is a S cube term, how many poles are there? 3 poles. If only first this term present, there is a single pole. So depending on your transfer function of closed loop amplifier system, first find how many poles are there, then draw its Bode diagram. What do we draw then? Bode diagram. So what I do is the following. Okay. Here is some my definition, I will come back to it again. As I say, we can dwell on this detailed theory of feedback. It is a huge game, interesting game, rather much more interesting than many things I taught. But I like it, that is what it is. Root locus technique, it is a very funny thing, Nyquist criteria, how many times you circle the pole, very nice thing to learn. हो गया, आपको एक फिगर दिखा देते हैं जिससे आपको थोड़ा सा एक स्टेबिलिटी का आइडिया आ जाए. ये सिंगल पोल है, I have plotted for the transfer function, loop gain, a single pole theory, single pole as I plot for the amplitude, and this is its phase. At this point, what is the gain? Loop gain is how much? 1. Is less than 0 वो पॉजिटिव होता है ना, तो पहले 1 ही है अभी यहाँ पर, इसके नीचे वो माइनस हो रहा है, ठीक है, इसके ऊपर प्लस है. At this frequency, if I plot my phase correspondingly, 45 degrees per decade, and it intersects at point, let us say some 160 degree minus. What is the phase there? Minus 160 degree. Then I say I put another value where the phase becomes 180 and I get the value of frequency at which that has happened. So this value, is that correct? At this point this is the gain, at this gain this is the phase, at this frequency this is the phase, at this phase this is the gain. Is that clear? So we say at this, for the loop gain, from this value where the t has become 1 or 0 dB, you add 180 degree to it, okay, or subtract minus 180 means add 180 degree to it. If that quantity is positive, that is, this number is called phase margin. What is phase margin? This value, phase at this point where the t is 1, minus of minus 180 means plus 180. So 180 minus this phase value if you do, and if this value remains positive, then what is the phase margin will be called? Positive phase margin. We have just now said if it is less than 180 degree, the output signal will never be in phase by feedback to the input. So which feedback it will retain? Negative feedback, because the signal is not returning to same phase, 180 from the amplifier, 180 from here, so 360 degree nahi ho raha hai. So as long as this is less than 180 degrees, system will remain always stable. Is that correct? So what is the criteria I am saying? If the phase margin is positive, the system is always stable. When this would have occurred, let us say at this value or this, when the gain has become, यहाँ पर समझो ये एक वैल्यू है गेन की, और समझो ऐसा कुछ हो जाता, ऐसा अभी होगा नहीं बट ऐसा समझो होता. So you have reached 180 degree, sorry यहाँ पर you have reached 180 degree but the gain is still positive. Is that correct? So which feedback it would have given? Negative, positive feedback. So if the phase margin becomes 0 or negative, the system will become unstable as long as the phase, and what is the definition of phase margin? There should be the phase of t plus 180, why it is plus I wrote, minus of minus 180 is plus 180, so 180 and this will be minus, so if the net value is positive then we say feedback is always negative, otherwise feedback is positive and system will become unstable or instability starts. Is that point clear? Is the definition clear to you? I repeat, if the return signal is in phase as is more than unity, which means it will add to the signal and output will grow, is that correct? If it is not in, it opposes the input, it will always reduce the V0 and therefore it will never grow, is that clear? So for stability negative feedback is essential, and to do this phase margin must be retained to less than or greater than 0 degree, or rather prefer, what is typical amplifier phase margin should be for normal good this, remember 45 degrees per decade एक कैपेसिटर देता है, ठीक है, फेज में 2 आया तो 90 कर देंगे उसके, तो इसका क्या मतलब है कि मिनिमम कितना रखना चाहिए, अननोन एक कैपेसिटर कहीं से यदि फीडबैक पर आ गया, अननोन यानी इसको क्या बोलते हैं, ऐसे कौन से कैपेसिटर जो अननोन रहते हैं, पैरासिटिक, वो आपको सिस्टम को अनस्टेबल बना सकते हैं, तो कम से कम 45 डिग्री तो भी आप फेज मार्जिन रखिए जिससे आप गारंटीडली उसको निगेटिव फीडबैक में, नॉर्मली फेज मार्जिन फॉर नॉर्मल एम्पलीफायर शुड बी केप्ट बिटवीन 45 to 60। अब मैं अभी आपको नहीं बताऊंगा, पर सोचो यदि फेज मार्जिन 80 कर दिया, 90 कर दिया, और भी अच्छा स्टेबल होना चाहिए ना, तो कुछ तो भी और चला जाएगा, यू मे अचीव वेरी नाइस, क्या हो जाएगा, गेन ही चला जाएगा, so you don't want to reduce the gain too much, at the same time you want it to be stable, so phase margin की typical value कितनी होनी चाहिए, 45 डिग्री to 60 डिग्री के बीच में ही सभी एम्पलीफायर स्टेबलाइज किए जाते हैं, not that 65 will not stabilize, but what cost, the gain actually will go down, okay, so a typical अच्छा gain और अच्छा स्टेबिलिटी के लिए फेज मार्जिन को कहाँ रखना है, 45 to 60 डिग्री में, ये कहाँ से आते हैं फेज मार्जिन, टैन इनवर्स जो आप निकालते हैं टी फंक्शन के लिए, उनके उसमें टी फंक्शन में क्या क्या वैल्यूज है, ए और बीटा, इज दैट करेक्ट, ए में क्या क्या वैल्यू होंगे, गेन होगा, जीएम होगा, सी होगा, आर होंगे, सब होंगे वहाँ पर, उनकी वैल्यू ऐसी होनी चाहिए कि वो ये 45 डिग्री तक या उसके थोड़े ऊपर फेज मार्जिन दें, if they give it then we say system is, amplifier is always stable, is that correct, otherwise even if you had thought it is stable initially, at some frequency you will find suddenly unstable हो गया, okay, and that is why I say amplifier design is very interesting if you have a feedback, is that correct? Please remember what is the phase margin, I keep saying you 180 plus, and this will be minus quantity, is that correct, because this is going down, so minus, then at 180 degree whatever is the gain from 0, ये 0 है और 180 पर ये गेन है, इज दैट क्लियर, 180 पर क्या गेन है, इतना गेन है, ये गेन फॉल हुआ ना यहाँ तक, यहाँ आया, तो 0 से यहाँ तक इसको बोलते गेन मार्जिन, प्लस है या माइनस है, माइनस है, सो यदि गेन मार्जिन प्लस हो गया, इसका क्या मतलब होने वाला है, फेज मार्जिन निगेटिव होने वाला है या 0 होने वाला है, उसका मतलब अनस्टेबिलिटी, तो गेन मार्जिन निगेटिव होना चाहिए और फेज मार्जिन पॉजिटिव होना चाहिए, तभी सिस्टम स्टेबल होगा, इज दैट क्लियर, इज दैट क्लियर, दिस इज समथिंग इंटरेस्टिंग विच फीडबैक एम्पलीफायर्स प्रूव, प्लीज डू दिस बिफोर वी क्विट ऑन दिस, लास्ट एक स्लाइड दिखा देते हैं, इसका फायदा कहाँ हम उठाते हैं, हमने आपको एक बोला था कि निगेटिव फीडबैक से हम फ्रीक्वेंसी बढ़ाते हैं, बैंडविड्थ बढ़ाते हैं, दैट्स व्हाट आई सेड, इजंट इट, आई शुड डे वन आई सेड 1 plus a बीटा टाइम्स जो ओरिजिनल बैंडविड्थ होगा वो बढ़ जाएगी आपकी, तो इसका एक एग्जांपल है, मैंने सब सॉल्व नहीं किया, मैंने थोड़ा सा आपको सिर्फ दिखाया, डायरेक्ट वैल्यू एक्सप्रेशन लिख दिए मैंने, ये कैपेसिटेंस ऐसा फीड यहाँ से यहाँ लाया, कौन सा फीडबैक है ये, शंट आउटपुट वोल्टेज से सैंपल किया गया है और नोड पे पर रिटर्न करंट दिया गया है, तो इट इज शंट एम्पलीफायर, इज दैट करेक्ट, शंट एम्पलीफायर, whenever I connect a capacitance between output and input, we can separate them by which method? Input side, output side, Miller's theorem. तो ये इसको बोलते हैं, जो मेथड मैं आपको बता रहा हूँ उसको बोलते हैं मिलर्स कॉम्पेंसेशन. क्या बोलते हैं? मिलर्स कॉम्पेंसेशन. अब हम एक स्टेबिलिटी का एक आइडिया देखो. समझो यदि दो पोल हैं और वो पास पास हैं, तो विल देयर फेज विल रीच 180 फास्टर. इफ द टू पोल्स आर वेरी क्लोज, 90 से नीचे आना शुरू होगा ना, 90 dB. सो तो वो 180 आने में तो बिफोर 10 टाइम्स होने के पहले वो 180 पहुंच सकते हैं, 10 टाइम होते होते. तो इसका क्या मतलब है कि गेन वुड नॉट हैव प्रोबेबली गॉन टू 0, बट योर फेज माइट रीच टू 180. सो व्हाट सिस्टम विल बिकम? अनस्टेबल. सो क्या चाहते हैं हम कि यदि दो पोल एक दूसरे से दूर रहें, बहुत दूर रहें, तो जो डोमिनेंट पोल यदि पहले आ रहा है काफ़ी शिफ्ट होके बहुत कम जगह पे जा रहा है, समझिए थोड़ा बैंडविड्थ कम करने की कोशिश की गई है, तो क्या हो जाएगा? फेज विल नेवर रीच 180 बाय देन. इज दैट करेक्ट? बिफोर द गेन क्रॉसेस 0. इन दैट केस व्हाट विल हैपन देन? सिस्टम विल रिमेन स्टेबल, बट एट व्हाट कॉस्ट? बैंडविड्थ थोड़ी कम की मैंने, क्योंकि मैंने शिफ्ट किया उसको थोड़ा लेफ्ट में, तो उसकी बैंडविड्थ थोड़ी रिड्यूस करके मैंने क्या अचीव कर लिया? फेज मार्जिन अचीव कर लिया मैंने. सो दिस को बोलते हैं कॉम्पेंसेशंस. तो क्या कर सकते हैं कि ये जो इनिशियल पोल है, समझो एक सर्किट है, अभी ये CF नहीं है, समझो फीडबैक. ओके, एक इक्विवेलेंट सर्किट है, R1 एक रेजिस्टेंस है, C1 एक है, ये आया है, इज द करंट सोर्स, दिस इज माय V0 और I0 भी ले सकते हैं, और ये फीडबैक नहीं लिखा है, नॉर्मल एम्पलीफायर है, इसको निकाल दिया मैंने. सो व्हाट आर द टू पोल्स वी से विदाउट फीडबैक? नो CF. It is not AOL kind, it is just that there is no CF. Then R1 C1 will be one pole and R2 C2 will be other pole. So omega P1 is 1 upon R1 C1, omega P2 is 1 upon R2 C2. These are the two poles available for you. Okay. If I use this now new circuit, I evaluated the transfer function V0 by that and I evaluated the two poles. अभी आप इक्वलेंट लिख लो, ये एग्जैक्ट नहीं है, ऐसे हैं. दिस इज द पोल्स विदाउट फीडबैक, नो CF. दीज आर द टू पोल्स विथ CF. ओके, इस फंक्शन में देखो ओमेगा P1 डैश में, इफ आई इंक्रीज CF व्हाट विल हैपन? ओमेगा P1 क्या बढ़ेगा कि कम होगा? कम होगा, यानी लोअर साइड में जाएगा, कम होगा यानी लोअर साइड में, तो बैंडविड्थ थोड़ी कम हो रही है. ठीक है, ओमेगा P2 को देखो, इसको थोड़ा मैंने नाइस एक्सप्रेशन बना दिया आपके लिए, GM अपॉन C1 C2 बाय CF प्लस C1 प्लस C2. तो CF बढ़ा है तो क्या होगा? ओमेगा P2 को बढ़ेगा, यानी वो राइट साइड में शिफ्ट होगा. तो डू यू सी, बाय चॉइस ऑफ ए CF आई एम सेपरेटिंग टू पोल्स P1 एंड P2. स्प्लिट, समझ में? वर्ड स्प्लिट क्यों हुआ? ये किधर गया? लेफ्ट में, ये किधर गया? राइट में. तो पहले यदि पास थे तो उन दोनों को मैंने सेपरेट कर दिया. किस मेथड से किया सेपरेट? शंट कनेक्शन दिया CF का. सो आई नाउ फिगर आउट बाय चॉइस ऑफ CF वैल्यू आई कैन मूव द सेकंड पोल टू माय राइट एंड वन पोल टू माय लेफ्ट. सो दिस इज कॉल्ड स्प्लिटिंग. सो तो टू पोल को स्प्लिट कर दिया. जैसे ही मैंने टू पोल्स को स्प्लिट कर दिया, अब किसी भी हालत में जितना स्प्लिट करेंगे आप, उतना फेज मार्जिन, फेज विल नेवर रीच 180 डिग्री बिफोर क्रॉसिंग ऑफ दिस वैल्यू. इज दैट करेक्ट? आप समझ सकते हैं, यदि इसको और शिफ्ट किया तो यहां से ही जाना शुरू हो जाएगा, तो क्रॉसिंग ऑफ 0 dB विल बी अर्लियर बिफोर द फेज बिकम्स 180. सो व्हाट डज दैट मीन? सिस्टम विल बिकम स्टेबल. सो बाय स्प्लिटिंग द पोल्स I can make even an unstable system close to stable system. What is the method I suggested? It's called splitting of poles. By adding a shunt feedback capacitor, all that I did, one of the poles I took left, other pole I shifted right, separation कर दिया. अब वो इतने फास्टली फेज डिक्रीज नहीं कर पाएंगे. Is that correct? So they may never reach 180 degree, minus 180 degree before the gain goes to 0 degree. If that happens, what is the phase margin I will get? Positive, which means system will become stable. Is that clear? So any system which is unstable can also be stabilized using feedback. Is that point clear to you? So that is the trick which we are saying. Even if the system is unstable, I have way to actually stabilize it. What things I will reduce? I will reduce the gain. I may reduce some bandwidth otherwise to some extent, but I will make system stable for you. Is that correct? This is what the feedback is all about. Okay. इसलिए stability word समझ में आ गया कि क्यों system should not remain in growth path, it should remain stable gains. So feedbacks allows you to achieve any stable. ये क्यों ऐसा सब कर रहे हैं, किसके लिए कर रहे हैं? In nature, the input signals which you receive from any of the like noise coming or any transducer you put to pick up temperatures, variations, all these are in nanovolts to microvolts. Spring का है, mechanical systems है, इनके जो source हैं इनकी value बहुत थोड़ी है. Is that correct? Now I want to do some processing, so I must first amplify them. Is that correct? Once I start amplifying, what is my problem? वो सिग्नल इतना छोटा है, उसका गेन बढ़ाने जाऊंगा तो मैं अनस्टेबिलिटी कर दूंगा. तो मैं क्या करूंगा, पहला स्टेज कौन सा होना चाहिए? फीडबैक ही होना चाहिए, क्योंकि वो लोअर गेन से स्टार्ट करे पर जो आउटपुट लेके आए वो स्टेबल हो. सो अब सेंसर का आउटपुट मेरे को करीब करीब फिक्स्ड मिल गया है. इज दैट करेक्ट? फिर मैं नॉर्मल गेन स्टेज भी दे सकता हूँ. इज दैट करेक्ट? So in all instrumentations, signal processing or any kind, the first stage is called low noise amplifier, which is essentially a feedback amplifier with a low gains. Is that correct? Why it is necessary? Because I want signal to be slightly larger than what I, even in antenna, जो आपका मोबाइल है इसका सिग्नल लेस देन ए मिलीवोल्ट है. ओके, आपको तो कुछ सुनाई भी नहीं देगा, यदि 3G है तो दिखाई भी नहीं देगा. So what should we do? We must amplify it. But as soon as I put a normal amplifier, क्या होगा, वो एक्चुअली नेगेटिव में पॉजिटिव में चला जाएगा. तो उसको बूस्ट तो करना है पर इतना भी नहीं कि वो अनस्टेबल हो जाए. तो उसको पहले स्टेबलाइज गेन कर देते हैं, छोटा गेन छोटी बैंडविड्थ पे पहले बूस्ट कर देते हैं, फिर थोड़ा सा बढ़ा 10 मिलीवोल्ट हुआ, फिर नॉर्मल एम्पलीफिकेशन किया जा सकता है. इज दैट क्लियर टू यू? This is the take why we are so worried about, particularly for all signal processing applications, including communication in networks and everywhere. This will be the first stage of any input part. Is that correct? So you need to understand why feedback is so much relevant. Is that clear? This finishes our feedback part.